Andri, Bu Rahmi, dengan Bu Pratya. Saya Lutfi Nurwandi dari Universitas Islam Bandung, rekannya Bu Nita. Bu Dokter Nita.
Waalaikumsalam, selamat datang.
Terima kasih sudah diundang.
Alhamdulillah.
Oh ya, dengan Assalamualaikum Pak Ari juga.
Waalaikumsalam.
Saya Lutfi Pak dari Universitas Islam Bandung, rekannya Bu Nita, Bu Dokter Nita.
Oh iya, iya Pak, selamat datang.
Iya, terima kasih Pak. Ya.
Iron ya. Iron apa kabar?
Assalamualaikum Bu Docki.
Ya, Pak Lutfi.
Iya. Gimana Trisakti dengan rektornya Pak Kadarsa sekarang?
Ya.
Selamat Bu ya, selamat Bu
Ya.
Pak Kadarsa.
Sama-sama teknik industri jadinya.
Iya, iya. Aman lah teknik industri kalau ada Prof Kadarsa.
Assalamualaikum Pak Lutfi, Pak adik Docki, saya masih adik Docki aja Pak.
Ya.
Ahmad ya. Ahmad ini.
Karena kalau NIM ini nggak bisa dihilangkan.
Ya adik kelasnya Pak Ahmad soalnya.
Ya.
Jadi junior.
Ya, saya nggak mau pakai umur soalnya, kalau pakai umur ya susah juga, saya juga udah ini. Nggak lebih muda kita Bu Docki ya.
Iya.
Kalau misalnya anak ITB tahun berapa, 2004 gitu kan, nah kan jadi muda gitu. Jangan yang 82-nya, jangan yang 74, 70 berapanya belum disebutkan. Anak ITB 2004 gitu kan.
Mana Pak Ahmad? Di Bandung apa di Padang?
Assalamualaikum Pak Prof. Hakim, alhamdulillah Prof.
Di mana di Padang nih?
Ya di Padang Prof. Wah, udah 2 tahun ini nggak kemana-mana nih Prof.
Kirain di Bandung.
Kemarin rencana Juli mau ke Bandung, mau ketemu Pak Tutun Prof. Tapi karena ada PPKM ini jadi nggak jadi deh. Sudah kontak Pak Tutun di stay.
Stay ya, they can stay sekarang.
They can stay ya Prof. Jadi ya karena saya sekarang kan saya
ya.
kalau disebutinnya di sini di toko sebelah saya nih, di warung sebelah, jadi saya kalau susah juga saya di warung sebelah, tapi di sini kalau di sini yang asli saya ini. Makanya ada Prof Hakim ini kembali ke jalan yang benar.
Assalamualaikum Prof Hakim.
Salam.
Prof dari Universitas Islam Bandung.
Apa kabar nih?
Baik Prof. Kemana Abang Prof?
Alhamdulillah.
Katanya Unisba ini Universitas Sumatera Barat lah Prof Hakim. Karena banyak orang Padang juga di sana Pak Lutfi ya.
Iya. Iya.
Yang pastinya banyak orang Sunda Pak.
Oh iya. Assalamualaikum Bu Nita.
Nita, apa kabar Bu Nita?
Alhamdulillah baik. Dibandingkan dengan selain Sunda dan Bu Nita. Selain Sunda Bu Nita.
Selain Sunda, iya.
Selain Sunda, orang Minang banyak katanya.
Banyak. Tapi orang Minangnya bisa bahasa Sunda Pak, hebatnya di Unisba mah.
Iya.
Karena di Unisba tuh defaultnya bahasa Sunda, jadi ketemu dan langsung kumaha ada mang.
Iya betul Bu.
Defaultnya
Betul,
itu.
bagus, gitu, Bu.
Dengan karyawan, sama dosen.
Bonita sehat Bonita?
Alhamdulillah Pak, sehat di Bandung Maraos.
Assalamualaikum Prof Hakim. Alhamdulillah. Assalamualaikum salam.
Salam Pak Yuri.
Apa kabar? Apa kabar Pak Yuri? Sehat ya?
Sehat. Sabtu belajar nih.
Soalnya ya kalau yang begini-begini nggak ada hari lagi selain Sabtu.
Kalau dosen sih kapan aja ya belajar.
Iya, apalagi sekarang udah nggak bisa bedain hari apa. Pertemuan tuh kalau ngundang enak aja sekarang. Gimana kalau jam 8 habis isya lah katanya.
Iya. Sebenarnya banyak manfaatnya juga ya. Maksudnya melebihi dari keadaan normal gitu kita.
Iya. Tuh bilang habis isya tuh seperti tidak bersalah gitu.
Good morning, ladies and gentlemen. Welcome to the webinar series of Production, Planning and Control Session 2. We are honored to have you all here. This session will be hosted by Ibu Dr. Docki Saraswati. To Ibu Docki, the time is yours.
Thank you, Mrs. Praya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning. First of all, I would like to welcome all of you and thank you for participating in the webinar series in Production Planning and Control in Session 2. We have been almost 2 years confronting the COVID-19 outbreak, and we have the limit of social interaction among all people. In such a condition, keeping connected with other colleges while taking the most advantage of information and communication technology will be an excellent platform for us to remain productive in academic activities, even though we have faced a hard constraint of the COVID-19. The idea of having a webinar series is remarkable because the webinar series will keep us connecting and friendship. The webinar is organized by Manufacturing Research Group, Institut Teknologi Bandung, with the collaboration with the Industrial Engineering Study Program from 6 universities. Our appreciation and congratulations delivered to Dr. Sukoyo and his team for their hard work in realizing the webinar series in production planning and control, especially in production scheduling area. Our today distinguished speaker is Professor Abdul Hakim Halim. He is a professor at the Industrial Engineering Department, Institut Teknologi Bandung. He received his degree in Industrial Engineering Doctor from University of Osaka Prefecture, Japan, and Bachelor and Master from Institut Teknologi, Bandung. His research interests include scheduling, inventory, manufacturing, system design, and he published his research outcomes in the several international journal and international conference proceedings. This webinar will be held on Saturday, once in 2 weeks until March 2022. The next webinar, the speaker will be the PhD holders under Professor Hakim's supervision at the Doctorate Program of Industrial Engineering and Management Institut Teknologi, Bandung. And I am proud to be one of his students when I was at the doctorate program. The motivation of the webinar series is to collaborate in research and education among us and among our institution. The audience can also observe the topics, the approach, and the depth of the research substances if anyone is interested in pursuing the doctorate program at Institut Teknologi, Bandung. Benefit of this webinar is whether the audience is interested in joint research and publication with any of us. Therefore, please take the advantage of this webinar series. Finally, after the first session, we have the understanding of what industrial engineering problems are and the solution methods, and mostly research of Professor Hakim in batch scheduling. Today's session, Professor Hakim will share with us the introduction to research problem on batch scheduling. Please welcome our distinguished speaker, Professor Abdul Halim.
Thank you, Dr. Docki. Thank you for your nice introduction. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Bismillahirrahmanirrahim. Good morning, all distinguished participants. Welcome to my second session in this webinar series. In the first session, I presented a topic on industrial engineering problem and the solution methods. I do hope we have now had the same understanding about when to consider a problem we are facing, an industrial engineering problem, and how to solve the problem effectively. Today, I will present a topic on more detail about examples of an industrial engineering problem and the solution methods. I will introduce batch scheduling to minimize total actual flow time. I first deal with this problem in 1990, means 31 years ago, when I was in my first year at my doctorate program in Japan. The so-called just-in-time production systems inspired me a lot to include due date in our decision on the production plan. Okay, I will start my presentation and let me share my PowerPoint. Has my PowerPoint appeared?
Yes, Prof.
Yes, Prof.
Okay. So my title of this presentation is Introduction to Batch Scheduling to Minimize Total Actual Flow Time. Manufacturing companies face fierce market competition because at least two reasons. Many productive companies operate in the same markets. And the second, customers require customized product with high quality, low cost, and on-time delivery. Customized product means manufacturing company should be able to produce anything at any time. And response should be made in two dimensions. First of all is technology dimension. This to make our production system responsive. and it means that flexible processor to vary produce product service so that nearly everyone find what exactly they want. And the second dimension is organizational dimension, and this is related to production planning and control, how to shorten manufacturing lead time. I have a data about research in America and in Germany about manufacturing lead time. So manufacturing lead time can be defined as interval time between arrival time and delivery time. And manufacturing lead time is the summation of moving, waiting, setup, and running. And then from the research, it could be found that moving and waiting takes 95%. So it's the biggest portion for manufacturing lead time is for moving and waiting, according to the research in America, in USA. And setup is 3.5%. Moving and waiting, they combine moving and waiting in one factors, and running only 1.5%. It means that activities without added value is 98.5%, and with added value only 1.5%. And the research appear in Windal book. Moving and waiting is separated. For moving 2 to 5%, and for waiting about 85 to 92. So it's actually similar to this. And then running compared to this, because in research in Germany, setup time is including into running. So we can conclude that from this two pieces of research, it's about the same. How much the contribution for activities without added values is very, very, very high. And we can see also that to overcome the problem of moving, this can be solved by plan layout and material handling. And for running problem processing, it can be solved by production technology. So this both is included into technology dimension. And then the second dimension is about waiting, and how to solve the waiting is about production planning and scheduling. So we can see the contribution of production planning and scheduling to shorten manufacturing lead time is very amazing. Production planning and control consists of production planning. So this is from planning. Planning is to create production plan. It's not to implement, but to create production plan. So it's something like design. So this is industrial engineering problems. And the second one is production control, aiming to adjust the current production plan if it is different from the practical condition at the shop floor. So we have to monitor here, of course, and then we take action to adjust our current production plan if there is a different from the practical condition. So we can conclude that production planning and control is one of the stages of the manufacturing cycle. So we can see later that PPC is one of the stage of manufacturing system, and this may be used to shorten manufacturing lead time. Last week, I introduced you a manufacturing cycle, start from market research, product design, process design, production planning, production activity, production control, and if there is no problem, and go to warehousing, distribution, and back to market research. And our production planning and control is only here. So to make short, to make manufacturing lead time short, we can take advantage to improve in this production planning and control. But actually, we can also do improve in distribution process, in warehousing process, in market research, product design, how to make, how to design that make product easy to be processed, something like this. So process design, which machine, that, and so on. So all of this manufacturing cycle can be improve the performance. So production planning, we know that started from demand and forecasting, and then aggregate plan, and the aggregate plan is disaggregated to be master production schedule, and then MPS will be an input for manufacturing requirements planning, and the output of material requirement planning is outsource component, and then we can order to outsource, and then production schedule and modified schedule, because before this is accommodated, we have already had a schedule, and then with the existence of new order, we may have to modify the previous schedule. And both then to activity of production. And we always monitor here and take action if the plan, decided plan is different from the production activity at shop floor. And we also do capacity planning. First is rough cut capacity planning to check whether the MPS is can be fulfilled, and then capacity requirements planning is conducted for checking the material requirements planning. And I would like to say that actually demand forecasting, this is beyond the production planning and control, because actually demand forecasting is to forecast market. So how many parts is required, is demanded by market. And then if, for example, market required 1,000 parts, and our competitor has taken, let's say 700, so it means that only 300 available for us. So this will be the maximum number that we can produce, because from all of the forecasting result, we only have 300. So actually, this is beyond the production planning. And also, I would like to say that demand forecasting is could not be based on historical sale, historical sale data. This can be done if the company has the biggest market share. So if the company dominates the market, we can use this one. But if we are a small company, we cannot do this method actually, but we have to do like this and then minus the part that has already been provided, and then this is the maximum number that we can produce. Okay, and we can see that this part is for strategic planning, and this part is tactical, and this is operational. So I would like to remind you all that aggregate plan means it is in a family level. It means that there are many items. Accordingly, we actually should make a planning like this. This is for MPS1. This is also rough cut capacity planning, and also for MPS2. And also, of course, this here also RCCP2 and the third, and so on, until all part produced by the company has the MPS. So, for example, for Toyota Motor Corporation, maybe there are many kind of product. There are Camry and so on. So this is maybe for Camry, this is maybe for Fortuner, this is also for other kind, and so on. And then this is we call as item level. Item is the product that are used by customers. And then MRP, we do also capacity planning, and also for the second MPS, and we say it's component level. And then all the output of MRP will be operated at shop floor. So this is two. One is outsourcing, the second is modified schedule, and the third is production order release. So this is production order release. Okay, so we have three outputs of MRP process. And this also lead to a situation where maybe many parts, many components should be processed on the same machine. So it's like this. So one machine, they have to process many products. And another machine also may be the same. They have to process many kind of product. And maybe there's a flow shop that should process another group of product. So this is derived from MRP. Yeah. So it means the scheduling is derived from MRP. So we can see here that after aggregate planning, master production schedule, and then we do production schedule in an inventory planning separately, and then we send to production activity. It means that we have two decisions here, and could be conflict. So this kind of planning that we are doing right now actually is not appropriate. So we should actually, after aggregate plan, master production schedule, and production and inventory planning, this should be integrated first before we bring it to production activity shop floor. So this is what I'm offering with this research. So now we know that we have two kinds of problem: inventory control and scheduling problem. And this is, we know, economic order quantity, economic manufacturing quantity, and we know reorder point. Yeah, this is actually manufacturing lead time, but it is given. And then we process the AO key and M key. So the most important thing that we should be remember is this is based on given MRT. Yeah, and we also do minimizing inventory costs, but the question is whether cost represents the number of inventory. Okay, and we see on the scheduling problem side, yeah, there is manufacturing lead time. Means that after we decide a schedule, we just know how much the MLT. We cannot give the MLT given because MLT is determined by a schedule. Yeah. After we deciding a schedule, we can compute the MLT. This is maybe by SPT or by any other methods. And then here is minimizing flow time. Yeah. And we should integrate this. Inventory models and scheduling model, we should integrate in inventory and scheduling model. But this is still a job, scheduling. Yeah. We have also changed job scheduling to be batch scheduling. Why? Because batch scheduling could be the first step toward mass customization. Mass customization means customized product with the cost of mass production. And we use the criteria not minimizing flow time, but minimizing actual flow time, guarantee the arrival time and delivery time, because consider the due date. Yeah. So why we do research on batch scheduling? First of all, scheduling is a significant tool to reduce manufacturing lead time. Minimizing flow time is one of the shop time criteria frequently used in solving scheduling problem and is considered as an indicator of success in quickly responding to customer. But unfortunately, the traditional flow time definition doesn't include any due date representing consumer satisfaction. And also it has been developed now, new measure. So to overcome this, so we offer actual flow time. And now this has already been implemented into many models, many scheduling models. So we have developed a new measure called actual flow time. Researchers should pay more attention. Yeah, the third reason, researchers should pay more attention to batch production system, as it is a bridge to the so-called mass customization. We know that efficiency and variety of the product, we can see that this is a job shop, and means that efficiency is very low, but can make a variety of product. And then this we call as customization. And then flow shop is efficiency very high, but the volume is very low. Yeah, of each kind of product. And between job shop and flow shop, there is a batch production. And actually, what we are expecting is this one. The process that can be efficient and also flexible. So in this, Actually, this is related to flexibility. Jadi, we want to have a manufacturing system that's efficient and flexible. And this is we call as smart manufacturing. And the response system is mass customization. Customized product, but with low cost. So that's why we have to start study batch production, because this will be very easy to go here compared to go here from here or from here. So from here is we should through batch production systems. Why batch scheduling is important. There are many batch production systems found in practical situation and facing production scheduling problems. Yeah, many batch production systems. And the research on batch production system for discrete manufacturing or in continuous, so both we can do. And the research open a new class of research in production scheduling problem. Scheduling problem should be solved simultaneously with inventory problem. So this is the integrated model. It integrated two problem areas, inventory control and production scheduling, to have a comprehensive plan. So the characteristic of research problem. So this is, we have due date, and we arrival just in time. So this is arrival just in time, and this arrival delivery. So how we want to decide production scheduling with these two just in times. And we then want to improve our manufacturing time. And this is go to batch scheduling, but it's close related to inventory problem. And the criteria here also not batch production system, but not job production system, but batch. And we solve the problem at a shop floor. And because this is batch, it could be for discrete manufacturing or continuous manufacturing system. So this is, for example, there are an independent defined job that should be scheduled on a machine, and all have already been. So this is the assumption. All jobs have already been in the shop floor since time zero. And this is to be processed on a single machine. Processing and sequence independent, no due date. The machine is always available during the planning. So this is the assumption for previous methods to deal with production scheduling. So the problem is only to sequence jobs as the size of the job have been given in advance. So we can use the scheduling priority rules, short processing time, longest, and so on. So we have job 1, job 2, and then we try to make a schedule to show the position of job 1 to where is the positions. And this question is, what happens if the quantity of each job is more than 1? In this case, job 1, 2, 3 or consists of only one job. Yeah. The question, what will happen if the quantity of each job is more than one part? Do the priority rule, SPT, LPT, still work? Okay, so now there are different part, and the decision is batching. We have to batch first. How many batch and how the batch size? The first decision. And the second decision is about scheduling. So it means this is a part to be processed, and then we have to decide how many batches and what is the batch size. And the second is how to schedule these resulting batches. So now we have to find the schedule of the batch. Yeah. And the question is, which rule should be adopted to schedule the resulting batch? So to understand better, we will give you an example. Suppose there are 12 jobs of a type to be processed on a single machine. Processing time T = 1 and setup time for a batch is 3 time unit. A batch is a number of parts processed with one setup. If the 12 jobs are processed as one batch, and then this is the Gantt chart, and we can compute flow time of this schedule as 15. Yeah, this is for batch, and for part of the batch, because in this batch we have 12 and each part 15, so the total flow time for all parts at the shop floor will be 180. If they are processed in 2 batches, and let's say the same batch size, 6 both, and we can have the Gantt chart like this, and we can have the total flow time of part at the batch at the shop is 162. 6, this is 6 part, and this is 9 time unit. So this is the actual flow time, and the flow time, and then this is also 6, and this to this is 18. So the total will be this. If three batches, we can get this flow time. But this is the problem without due date. Yeah. So this is for different, still 2 batches, but different batch size. We also have different. So the number of batches and batch size will determine flow time. So accordingly, there should be a number of batches and batch sizes leading to best solution. The resulting batches are then scheduled according to rule. So we have to first design what is the best batch size. So now we go to batch scheduling with do that. But what is the formulation for batch scheduling? So we can see here flow time of batch I is, so this is for batch I, is S plus P. This is flow time for batch. And then P is T times T. And then this is flow time of part in batch E. This is flow time for batch, and this is for flow time for part. So it must be multiplied by T. And this is only for batch E. So the total is, of course, we just summing this flow time of part in all batches. So this is the formulation of the models. This can see in Dobson et al. And Dobson has also shown the solution. So this is for the number of batch, and this is for batch size. And this is the algorithm. So set the parameters, compute the number of batch by equation this, and compute QI and sequence using LPT rule. So Dobson also proved that LPT rule can bring to optimal solution. Okay, then an example, we can see for N5, T2, and S1, the solution is M4, and the batch size of each batch like this, and this is the Gantt chart. Yeah. And we have the flow time is like this. This is the minimum flow time. And another examples, same. Yeah, just to show you that the models work and the algorithm also effective to solve the problems. So the question now, what happened if the part to be processed have a common due date? So not without due date, but have a due date. And the traditional flow time could not be adopted, of course, because the definition doesn't include due date. So it means that we have to create a new. So let's have a look at these pictures. This is a traditional flow time. So all job already here because the flow time always computed from time 0. It means that all job have already been at the job shop. And delivery time coincide with the completion. It means that because the definition say that a flow time of job from here to here, it means that in this point, deliver. So the second assumption is delivery time coincide with the completion time. The first, all have already been at time 0, and the second is delivery time coincide with the completion time. And due date is not involved. However, due date represents customer satisfaction. So this cannot be used anymore for the current problem we are facing. Accordingly, we propose what we call actual flow time. So just like this, we can see this is also the same because like a mirror. This is for job. So our job at the production line at the respective starting time. So B mean starting time. So the part come here, and then we compute the actual flow time from here to due date. Completed part to be delivered at their due date, respectively, if there's multi due date. And we consider that the problem feasible if A greater than or equal 0. Okay, and then we try to formulate this, and this is actual flow time for batch. So for example, this one, T plus S minus S, and this is actual flow time for part in batch. In batch 1, for example, that's the multiply by G, and then this is total flow time. We this is the sum of all batches in the shop floor. So this is will be the objective function of our batch scheduling problem. So this is, we decide batch, and then we do schedule. Decision variable is the number of batch and the batch size and the schedule of the resulting batches. This is the model, the very simple model. This is an objective function. They say that the time required to process all parts should be less than or equal the interval between time 0 and due date. And this is all part in all batch is equal to the number of parts to be demanded. And this is the part process first, process last, or schedule first must be coincide with due date. So this is due date, and this is the part first schedule. So it should be coincide with this, and the other is follow discuss. And this is the non-negative constraint, and this can be found at my dissertation or in many papers published. Using Lagrange technique, we can solve the problem. So the number of batch, I mean that with batch size, and this is the number of batch. We can use this formulation, and if we apply this, to the problem, and if the resulting batches has already been decided, and then for scheduling we use this proposition. Suppose that there are n batches with batch size qi respectively. So the optimal backward sequence that minimizes total actual flow time is obtained from arranging batches in order of non-increasing batch. So this is, the schedule should be the greatest size and then smaller. So from here is LPT, but from here is SPT. Actually, we schedule from here, but we process from here, of course. This is the batch first process, and this is the process last. So this is the algorithm to solve the problem batch scheduling, and this is the example. Yeah. Example, and then this is the Gantt chart of. Okay, so we can see here, it's very interesting. If we use flow time and then job and batch, SPT and LPT, so difference. If we do LPT and SPT, but if we do with job scheduling problem and then SPT and LPT, batch, LPT and SPT. So it's very interesting solution. And then batch processor. So what we have already discussed is about job processor. What is the difference? Suppose there are 12 part processing time T1 and setup 3. So if the parts are to be processed on a job processor, the batch processing time will be 12. So this is, yeah. But if in batch processor it's only 4. Yeah. This is not to illustrate that it is better to process with batch, but it's just to show the difference between job processor and batch processor. So we don't have to use key. So it's only this one. But here we have to multiply by t. Okay. And this is the same. We divide all parts to be several batches, but the difference is the characteristic of batch processor and job processor. So this is not TQ, but only T, because it's independent of the number of parts in the batch. So this is the criterion, the actual flow time through the shop for batch processor. Yeah, for batch processor. So the difference can be seen that Q is only 1 here. but for job processor, key in quadratic. This is the model. You can find this in the dissertation of Dr. Nita Hidayat for the basic model, and then this is the algorithm, and this is the example that we do for many examples. And this is the development, research development, the very basic, and then heterogeneous, and multiple due date, and flow shop. Yeah. So we can see here. Now we also working on deteriorating of machine, and also deteriorating of product. Yeah. So we can see that the complexity of the scheduling problems can be based on machine environment, job characteristic, and objective criteria, and also scheduling approach, whether backward scheduling or forward scheduling. And this is the coverage of best scheduling problem to minimize total actual full time. So we can see that job from machine with job processor, batch processor of combination. And for job processor, also for all situation is single, parallel, flow shop, or job shop. Except this one, single, no, it's not applicable because this is combination. And we have basic model here also. And then many papers has already been published. The position is at the cells of this matrix. So maybe there is still matrix still empty. It means that the research has not been conducted. So maybe we can develop the model into that condition. So single, we develop into multiple. Common due date, we develop into multiple due date. Single machine to parallel, or maybe to heterogeneous, or maybe flow shop, or maybe job shop. And the machine now deteriorating machine, and machine unavailable, and reliability maintenance, and also batch processor. So it's the same as a job processor. So we can extend for batch processor with the same logic. And this is the combination. And now we also working on deteriorating product. The product, for example, if we schedule at the position later, it means that the processing time will increase. So this is the deteriorating product. And all of this is the roadmap. And we also can develop to supplier, manufacturer, and delivery problem. And then in the short term to come, maybe we have to also continuous manufacturing system. So the concluding remark, main feature of the batch scheduling model to minimize total actual flow time. First of all is integrating scheduling and inventory model, simultaneously minimizing inventory and satisfying due date. Arrival and delivery just in time, various production system with various conditions, single or parallel, heterogeneous, full shop, job shop, and so on, and single to multiple item, common to multiple due dates, deteriorating machine and product. Operator, now operator also expanding to process of learning, forgetting, and tiring recovery, and also alternative operator. So I already explained this all. in the papers. Thank you. I guess that's my presentation, and please, if there is something to be discussed, no. Bu Docki, please take.
Docki is still mute, Bu.
Unmute, please.
Sorry. Thank you, Prof. Hakim. Now we come to the question session. There are two questions. First question come from Mr. Laksito from Universitas Atmajaya, Jogja. Could the GT techniques, it should be group technologies, be implemented in batching step in the batch scheduling? Does machine grouping influence in the schedule? This is the first. Is this directly the answer, or I have to read the two questions, Prof. Hakim?
Yeah.
One by one, or together?
Can you mention again the first questions?
Could the GT techniques
okay,
be implemented in batching step in the batch scheduling?
Yeah. Okay.
Number two, the question number two, does machine grouping influence in the schedule? There are two questions from Mr. Laksito.
Thank you. So for the first questions, GT Technique actually is dedicated to layout, to design the shop floor, the layout of the shop floor, the machine layout. And also GT technology also, for example, batching in the case of flexible manufacturing system. But in this batching is somewhat different, because we just want to process whether in single part by part or in batch or in batches. Yeah, we have two alternatives to process part. First one is one by one. First part process, and then the second part process, and then the third part. Or we do first batching and then process. So it's somewhat different between the concept of group technology and batching in this. And then grouping of the machine, those second questions, is also, we assume that the grouping of machine and so on has already been decided. So this is for the part that the process design has already determined. So it's not talk about a grouping anymore in this problem. Yeah, we just how to continue from material requirements planning to scheduling. Just this, that's it. So that's my question, my answer.
Thank you, Prof. Hakim. Mr. Laksita, is it answer your question? Okay. The second question from Miss Vina Sari Yosefin from Institut Teknologi Harapan Bangsa. The question is, for the batch schedule without due date in this case, do we always assume a single product type?
No. You can develop the model into multiple items. So the example I already discussed in this webinar actually for one part, but the model could be developed into multiple items. So you may do research in this field. Okay.
Okay, Prof. Maybe they answered the question of Miss Vina.
Okay.
The third question may be already answered in the first session we met, but it's okay. I will read again. How far the influencing of the Industrial Revolution 4.0 to production planning and control? This is from Mr. Masri.
Yeah, okay. I consider 4.0 is just a kind of technology. Whether we can adopt or we don't have to adopt the 4.0. And we adopt maybe for production or maybe to help we create the production plan. Yeah, so it's just a technology. Because of this, yeah, it's depend on whether the technology is needed to be included in our production system or no. I guess that's the answer.
Prof. Masri is from Universitas Kebangsaan. It may be from Malaysia, shit?
No, in Indonesia juga we have university.
Okay. And is any question? This is a long. Okay, I will read it. From Ms. Restu. The fourth question. This is a long question, Prof. Hakim. I will read.
Okay.
From Mr. Restu. In batch scheduling with due date, if we simulate with example of product manufacturing cases that have to use manual work, such as hand forming after the machining process, that we have done the batching method. How to assume that the batching method can be applied to manual work? First. Second, can the due date that has been determined based on the calculation formula will be realized considering the factor of scheduling complexity? Is clear?
No, the second one.
Second, can the due date that has been determined based on the calculation formula be realized considering the factor of scheduling complexity?
Okay.
Okay.
Thank you. Okay, for the first questions, actually the problem to be solved by this approach, we have to have the job descriptors, and machine descriptors has already been given. For example, maybe you talk about a flow shop. Maybe you talk about flow shop. It's no problem. So we can try to implement the batch scheduling model for flow shop. And many models have already been published in journals for flow shop models. So it's already no problem to implement this. But we don't have any model actually for job shop. We don't have any model for a job shop. But for flow shop, we have many models. So it's okay, no problem. And then the second questions, due date is not determined here. Due date is given parameters. So if you want to combine how to negotiate due date and the problem of this batching, maybe this is where will increase the complexity. Because in this model, due date is parameters, but you ask about how if due date is variables. So it's interesting. That also can be developed into new models. Thank you.
The next question from Ibu Nora Asmi from Universitas Trisakti. Can this batch scheduling problem be applied to industry with very large batches, such as the packaging industry?
Yeah, actually the requirements is if the job and machine descriptors are given. Yeah, job descriptors mean processing time, and then due date, and setup time, and the number of parts to be processed. And this is the job descriptors. And then machine descriptors is how many machine, flow shop or job shop, and deteriorating machine, and so on. So if all these descriptors are given, and then we can solve the problem by this approach. We don't specialize to any single problem, but we can do it as far as the requirement fulfilled. Okay.
Okay, Prof. Maybe Bu Nora ask me. The next question. We still have the time, okay, Prof. The next question from Pak Jauhar Arifin. Is the breakdown machinery already calculated in the schedule? How to predict the breakdown? What is the activity of the RCCP and CRP? Does this activity PPC team or production team? Who does this activity? Okay.
Okay. So actually we have consider the machine situation now. We call deteriorating machine. And deteriorating machine could bring the product non-conforming. So because of this, we also have published the model considering the breakdown machine, and also we have the model integrating the production schedule and maintenance process and maintenance schedule. Yeah, we have that model. Because of this, yeah, the machine breakdown also has already been considered in some models. Of course, in today's presentation, because that is a basic model, but maybe in the next presentation, maybe the third, fourth, fifth, and so on, maybe there someone, some presenter, some speaker would like to present this kind of model. And the second question about RCCP and CRP. RCCP and CRP is the function of the production planners. Yeah, so production planner should do capacity planning, because if we don't do capacity planning, and then the problem is about material requirements planning. And if we do feedback by this capacity planning, it's called closed loop MRP. So actually, we have been at a closed loop MRP, where the capacity planning should be made to make a feedback for the MRP and master production schedule. Yeah, so this is the function of planning. Okay.
The next question comes from Yuliza Idayat. The first question, why batch scheduling more important than the job scheduling? The second question, how we could integrate inventory control and the scheduling control to have the comprehensive result? Two questions, Prof.
Okay. I have already explained actually that batch scheduling is important, but it doesn't mean more important than job scheduling, because it depends on the case, the real case. but batch scheduling can improve many weakness in the job scheduling. For example, job scheduling, if we process one by one, it means we have set up first job set up, the second job also set up, and so on. But if this made batch scheduling, batch, and then one set up for several products in batch. And also with batching, we can go to mass customization. So if we have to choose which one, job scheduling or batch scheduling, and then the answer, in my opinion, if both can do that, we have to choose the batch scheduling. But maybe there are many problems that batch scheduling doesn't work because of the characteristic of the job. Okay, and then integrated batch inventory model and scheduling model. We can see that in this we have to decide the batch size. Deciding batch size is part of the problem in inventory control. But the criteria to decide the batch size is the criteria used in scheduling, flow time. So usually in inventory control, we use the criteria minimizing costs. But now we decide a batch size by minimizing flow time, which is the criteria of scheduling problem. So it means that this actually the integration of the problem scheduling and also inventory. But we have not explored this combination of problems. Yeah, I guess we have also models. One of the student graduated from S3 from doctorate program. There is a model integrating production activities and delivering activities. So it's two models, and then maybe we can try to integrate it from supplier side, and there are many problems of batching and so on. Thank you.
Yes, Prof. The audience so enthusiastic, so there is more question come.
Okay, no problem.
The next question come from Suryawan Arifandi. In mass customization, customer is possible to create their own product specification. That means customer create their own batch rather than use available batch. How to deal with this kind of challenge?
Yeah, mass customization, actually, we don't know what we are going to process because we know what product that we have to process after there is a demand, and demand every day changes, and it depends also to the customer. Different customer, different product. So for mass customization, it means that we don't know what kind of part to be processed. But mass customization means that we also take advantages of mass production. So mass customization is the combination of mass production as customization. Mass production comes to a lower cost. Customization comes to we can provide every customer. So it means that we have to decide which one that can be processed in mass production approach, and then which one in the customization. So in the whole of the production, there are mass production and also mass customization. So in the model, the batching schedule we are discussing today is about mass production. It's about the demand or the product descriptor has already been determined. So if we want to develop this, it means that we have to develop the model where the product can change anytime. Yeah, I don't have any idea for answering the question, but maybe we can think about that. We can develop that model based on the available model that already we developed in many cases. Thank you.
Okay, Prof. The next question comes from Mr. Eka Pakpahan. The question is, when we are doing MRP, we must perform time pacing by considering the manufacturing lead time. Most of the method there assume independency between MLT and schedule. But the schedule is to be determined in the next step after MRP. How do we resolve this conflict?
Yeah, this question is the question for motivating developing this problem. So I mean that the problem of MRP, where the lead time has already been given and all part has already been at the shop floor and so on, this is not the same as the real condition. Because of this, we try to improve the weakness of the MRP to the condition what we have in this model. But actually, the integration from first step in planning until scheduling has not been developed yet. So we try to do in the stage of production planning. But how about supply chains, and how about the determination of master production schedule? And you know that master production schedule also, we cannot have a fixed MPS, because MPS, master production schedule, depend on forecasting, and the forecasting is uncertain. So actually the schedule also uncertain. So we also actually we have a model how to deal with uncertain MPS to cope with the scheduling problem. We also doing this research. There is many proposed methods for this, and this also the last PhD from TMI, from Teknik and Management Industry, also deal with this problem. So it means that we try to improve, to revise the weakness of MRP methods, but we have not make an integrated of the all step in MRT. We just step in scheduling and deciding the batch size. But before MPS and then aggregate plan and so on, we have not deal with that.
Yeah. Next question from Mr. Iwan Kurniawan. How about R&D research of samples to apply in mass production schedule? Since sometimes become problem in continuous production.
R&D research on
in mass production schedule, to apply in mass production schedule.
Yeah.
Sometimes
yeah, okay. Actually, continuous process manufacturing is somewhat different also because it is different. If we see in our scheduling, it's based on product. Yeah, so the scheduling based on product. So this is we say product dominated scheduling. But for continuous process, it is different. Usually machine dominated scheduling. So this is somewhat different. Because of this, yeah, we have to learn much. So in my lecture, we have a lecture called production and production planning and control system, production planning and control system. So at program Magister TMI, there's a subject. We also explain about the batch process scheduling. So how to schedule in the is somewhat different, yeah, because the paradigm is different. We doing with product dominated scheduling, but continuous process actually is machine dominated scheduling.
Okay, Prof. Okay, Prof. Next question.
Yes.
From
Okay.
Bu Sidnah, Teknik Industri Darussalam Ambon. The question is, it is possible to make a batch scheduling as an analogy to a manufacturing cluster system, such as the industry as the machine, product of its industry as the part, and so on. Yes.
Usually, to make a cluster, we will be based not on this kind of scheduling problems, but on the group technology approach. Something like that. So it's somewhat different from batch scheduling we are discussing today, and how to make a cluster. This may be more based on group technology. So it's different.
Yeah. Okay, Prof.
Yeah.
Sorry to Miss Eka Pakpahan. It should be Miss, Prof. Not Mr. Yeah. Sorry, Miss Eka Pakpahan. The next question come from Ibu Tina Amran. Would you like to share the example of batch scheduling in services, such as surgery in operation room, for example? This question, Prof.
Okay. We can define a batch is a number of parts processed in one setup. So that's the basic definition of a batch. Number of jobs processed in one setup. Whether it is product or it is a service. If you can find there are many operations that conducted with one setup, it means it is a batch. So I guess it is also possible to do batching in service product, in service industry. And maybe for examples, yeah, with one batches, maybe you can do for operation in heart attack and another operation process is to prepare is the one setup, and then we can consider that is as a batch. But I guess for guiding, yeah, whether it is work for service industry, yeah, the definition of batch, several number of jobs that are processed in one setup. Yeah.
Butina Amran from Universitas Trisakti.
Yeah.
Next question.
Cataract. Thank you, Prof. I mean,
Yeah.
I asked you about cataract. Cataract is one time, can set up in one time, so we have many patients. But
Good.
for heart or for heart is different because we have to prepare in a very special treatment. But for cataract, for example, can you do it in best case? Thank you, Prof. Hakim.
Thank you. Thank you.
The next question comes from Pak Yusuf from ITG. ITG, it means Institut Teknologi Garut, is it right?
Yes, I know. He is also with us.
What consumer response strategy is suitable for batch scheduling? Make to order or make to stock?
Okay. We already recognize that there are many response to customers. First one is make to order, make to stock, and assemble to order, and so on. So the question is whether this response strategy fit for this. Yeah. Many problems that we have already dealt was for make to order, make to stock. Yeah, this is for make to stock. If we want to deal with make to order, it means that we have to understand what the characteristic of make to order production systems is. This also somewhat different because in make to order there is an offer, and to check the offer and to decide how much the cost, decide how long the product will finish. So it's many steps before we deciding that the product accepted or refused. So because of this, yeah, we have to cut the assumption from which step in make to order production system we implement this batch scheduling. Principally, it can be done.
Yeah.
Okay.
The next question comes from Pak Jin Ai, Universitas Atmajaya, Yogyakarta. The question is, are currently all the batch scheduling models can be solved using exact analytical method?
No.
No.
No. Many complex problems we cannot do. So, but the first step, we have to check whether the problem can be modeled in analytical approach. After we can model in analytical approach, the question is whether the problem can be solved with analytical methods. If we cannot model with analytical model, it means that we have to change to another approach. If we can model in analytical approach, but we cannot solve with analytical method, we have to try to develop, let's say, algorithm or something like that. So this is the process. And the last resort is do it with simulation. So for many complex, do simulation. But we have to try from analytical and then operation research and then heuristic algorithm, and the last is simulation. Yes.
Yeah. Maybe this is the last question. But yeah, from Pak Hendra Permana, Universitas Kebangsaan. How to measure the risk when the problem appear in in the apply of scheduling system? How to measure the risk?
Yeah. Actually, the development of the model is trying to release the assumption. Yeah. The very simple model assume that there is only a single machine, but we try to release this assumption to be several machines. And all of these problems also have the assumption that all are noun. Yeah, all are noun. All parameters are noun. And if we want to include a risk problem, it means that we are dealing with probabilistic or stochastic or uncertain even. So we have not gone that research area. Thank you.
Prof. Hakim, there are 2 questions, but this is almost 10:30. Is this all right? We continue or?
It's long to answer?
2 questions.
Okay.
But the first one is connected to Ibu Tina Amran question, referring to the service. This is for banking, serving to customer dealing the same problem in banking of our customer service. Is it? Prof. Hakim will answer this.
Okay. Or maybe you can write later. I will answer.
Okay. There's from Pak Suparjo Unti. The second from Mr. Evan Wiryawan.
Okay. Please send me the questions.
Send you the question?
Yes. And then I will answer and then send back to the Pak.
Oh, after the session?
Yes.
Oh, we close now?
Yeah, I guess because it's already 10:30.
10:30. Okay. Thank you very much for all the questions from the audience. And thank you, Prof. Hakim, for the fast response and so many things we can learn from Prof. Hakim today. And have a great day. And maybe we can meet in next webinar series.
Thank you.
To Ibu Pratya. Thank you, Prof. Hakim. Thank you.
Nggak ada foto-foto nih, Bu.
Thank you very much, ladies and gentlemen. Before we end up this session, we have photo session and will be guided by Please, Ibu Rahmi.
Ahmad sudah protes mau foto aja.
Okay, Bapak Ibu, ladies and gentlemen, please open your camera. The committee will take your screenshot. Maybe.
Bu Ami yang bertugas ya.
Now I'm the photographer, Pak.
Kalau.
Okay, we have 8 screen. So for the first screen, wait. Please keep your smile and open your camera. Maybe for some. Okay. First screen. Sorry for taking so long. Okay, second screen. Please keep your smile.
Kering nih, lama banget.
Nggak tahu di sistem apa ya.
Nggak tahu screen berapa saya.
Iya makanya. Ahmad
kering giginya saya.
Senyum terus aja.
Ya, Prof.
Pas lagi tidak senyum kepoto.
Itulah takutnya Pak Hakim.
Okay, this is the 6th screen.
Smile.
Okay, keep smile.
Bu Ami senyumnya nggak kelihatan gigi, nggak kering. Kelihatan gigi kering nih.
Okay. And the last screen. Okay, it's done. Okay. Thank you Bapak Ibu.
Terima kasih.
Terima kasih.
Terima kasih Docki.
Terima kasih Pak Hakim. Waalaikumsalam.
Terima kasih Pak Hakim, Docki.
Sama-sama semuanya.